I wanted to do a quick video for my Algebra 2 class, quickly summarizing some things that we talked about today. We emphasized today that we were looking at whether a function was odd or even, and whether the lead coefficient, I'm just going to put LC for lead coefficient, is positive or negative, because with those we were focusing on the end behavior. And so if we have a constant function which has a degree of 0, and we're looking at the end behavior is going to be the same all the time. Our limit as x goes to negative infinity, y is just staying the same. And so this isn't even a very good example to talk about end behavior. We're not going to go there with that. But a linear function, if you think about a linear function, we're talking about an equation y equals x, or y equals mx plus b. A linear function always has a degree of 1. And it's really the basis of what's happening with any odd function, because 1 is odd. So when you look at this linear function here, it has a positive slope. Well, when our lead coefficient is positive, which is what slope is our lead coefficient, we would say in this case that our limit as x goes to negative infinity. Well, what's happening here is x is going to negative infinity. Well, y is getting less and less and less and less, and so we say y is going to negative infinity. And our limit for this linear function is x is going to positive infinity, is that y is also going to positive infinity because it's getting bigger and bigger and bigger and bigger. Now, if we have a line that has a negative slope, in other words, our lead coefficient is negative, and we still have a degree 1, in the case of a line with a negative slope, well, that changed the game a little bit. In this case now, our limit as x is going to negative infinity, y is doing the opposite. Y is going to positive infinity, and in this case, as x is going to positive infinity, y is now going to negative infinity. And that gives you the basic idea of the odd functions. That is always what's happening, whether you're talking about an equation that has a degree of 5 or a degree of 3. Now, we might have more wiggles in the degree 3, degree 5, degree 7, but it's always going to have the exact same end behavior. For even degrees, for both end behaviors, y is either going to be going to positive infinity for both of the end behaviors or negative infinity for both of the behaviors. And a parabola is always a great one to look at. In this case, it's a parabola with a lead coefficient that's negative. So as x is going to negative infinity, y is going to negative infinity. As x is going to positive infinity, y is going to negative infinity. Even functions always have the same end behavior. Now, as we talk about a degree 4 equation, this is the one I like to say looks a little bit like a butt, oftentimes. But it's still going to have the same end behavior, but it's going to have more wiggles in it. It might cross our x-axis twice. It might cross our x-axis 4 times. So that's the first thing. So if I ask you about the equation f of x equals x to the 7th minus 2x plus 1, all we care about is this when we're talking about end behavior. Because what that tells us is that we have an odd number. We're not sure about the wiggles, but we could say a decent sketch of this might look something like this, because it's an odd function. Our limit as x is going to negative infinity, y is going to negative infinity. And as x is going to positive infinity, y is going to positive infinity. If we look at f of x equals 2x to the 6th minus 5, so we have an even degree and a lead coefficient that's positive, well, this is going to look something like maybe this. That's our butt. But we would say that the limit as x is going to negative infinity, y is going to infinity. Our limit as x is going to infinity, y is also going to infinity. An even function and behaviors are always the same. Now, the last thing that we didn't get to, how many roots will an odd function potentially have? Now, remember, roots means solutions. or zeros. And so when we're talking about an odd function, it's going to have an odd number of roots. In the case of our parent function of our cubic, this has one real root crossing the x-axis, but it always has as many roots as the degree is. So if we have x cubed, plus x squared minus 2x plus 1 equals 0, we're going to say that it has 3 roots. Whether they're real or whether they're imaginary, we're not sure yet, but it definitely has 3 roots, and some of them may be duplicated. How many roots will an even function potentially have? Well, if we have x to the 6 minus 2x squared plus 1, whatever your degree is, that's how many roots you're going to have. So that's the main thing you need to know. Now, I believe for this one, describe the end behavior and determine whether it represents odd degree or even degree, was definitely even degree, because our end behaviors are doing the exact same thing. And state the number of real zeros. Well, real zeros means where is it crossing the x-axis? And in this case, it's not crossing the x-axis at all. So we're going to say that it has no real zeros. And that means that basically it's going to have all imaginary roots, all imaginary zeros. So if it doesn't cross the x-axis, it doesn't mean it doesn't have solutions. It just means that they're going to be imaginary. Okay, and then it says describe the end behavior. This is definitely odd because our end behaviors are different. We would say that our limit as x is going to negative infinity, y is going to negative infinity. And our limit as x goes to positive infinity, y is going to positive infinity. And the number of real zeros, that's our only one. We have one real zero because it's crossing the x-axis once. Okay, for the graph, determine whether it represents odd, even, and then state the number of real zeros. Well, this one is definitely even because the end behaviors are the same, and we have 2 real zeros. So B. And that's the main thing you need to know for your homework. Thanks.